In this video, we're going to take a look at the VMware file system, VMFS. In nearly any type of storage other than NFS, the network file system, we are going to be presenting VMware with what either is a disk or appears to be a disk. iSCSI and Fiber Channel or Local SCSI all operate directly using the SCSI command set to drives, or what are often referred to as block devices. The disk is divided into different areas, and we need some form of a file system in order to actually place. The installation of ESXi goes on to a Linux-style partition system, but the virtual machines for ESXi need to go onto the VMFS file system, unless we're using NFS, in which case we're basically accessing a file share, and whatever file system is already on that NFS file server is what's going to be used. So in this case, I've connected to one of my hosts, and I'm in the configuration tab looking at storage. So we can see we've got two data stores listed here, ESX01-01 and another NFS01 without the dash. If I click over in the view section to devices though, we can see there's actually quite a few more devices that are recognized by the system that I haven't yet put VMFS on, and so they're not yet mounted as data stores. And we can see that I have a couple of 200 gigabyte local parallel SCSI disks. I've also got a couple of 8 gigabyte iSCSI disks, a 40 gigabyte SCSI disk, which is actually where I have ESXi installed, and whatever remaining space on that disk was already formatted as a VMFS file system. But the other disks that are already in the server or disks that are discovered are not going to have the VMFS file system on them automatically. They might already have a VMFS file system on them when we connect to them. If they're shared storage, for example, and they've already been formatted on another server, then when we connect to those devices, typically the VMFS file system will mount. Although we can still have difficulties with that. For example, if VMware detects it as a snapshot, it might not mount it for safety reasons. So I have all these devices. I'm going to have to put the VMFS file system onto them if I want to use them. So I'm going to go back over to the data stores view and click add storage. Now I've got an option to either connect to an NFS file share, in which case I'm not really using VMFS at all, or we can take a disk or logical unit number, a virtual disk that's been assigned to us via, iSCSI. Now potentially these disks might not have been discovered yet. If we're using iSCSI, we're going to need to have iSCSI configured, and if we're using Fiber Channel, we're going to need to do that. And if we create new devices in the SAN, we need these hosts to discover them by doing a rescan. In this case, all these disks are already recognized locally, so I don't need to do that. But we'll take a look at it a little bit later when we connect to iSCSI storage. So I'm just going to pick disk 1 and click next. And we can see that everything that doesn't already have VMFS on it that I could put VMFS on is listed here. I have my two local 200 gig disks and my two 8 gig iSCSI disks that I've already configured. We'll take a look at iSCSI in later videos. I'm just going to go ahead and click one of these disks. Now we have a choice for the file system version, either the older style VMFS 3 or the newer VMFS 5. We can see that one of the major differences between VMFS 5 and VMFS 3 is that VMFS 5 supports much larger volume sizes. One other difference though is that in VMFS 3, we actually need to select a block size. And depending on the block size that you choose, that's going to dictate what the maximum file size on that volume will be. So we had choices like 1 megabyte or as much as 8 megabytes per block, and that would allow us to create potentially much larger files. We don't need to worry about that anymore. In VMFS 5, the block size is always 1 megabyte, and there's also other optimizations for things like storing small files, VMX files for example, so that they don't take a whole block, and we have options for sub-block allocation and so on. So VMFS 5 is quite a bit easier. If you already had an environment, or data stores anyway, that were formatted as VMFS 3 and you need to upgrade them, that's also possible. So I'm just going to leave it at VMFS 5 and click next. And there's not really anything else that I have to do. I'm just going to go ahead and we can see the disk information. It will tell me if there's other partitions already on it and so on. In this case, I'm just going to go ahead and click next and provide a data store name. I have the option to divide the disk into different partitions effectively for VMFS. There's not that much reason to do this in most cases, but it's really going to depend on whether your storage supports something called VAAI, which is VMware Advanced Array Integration. When you use large data stores, or at least data stores that have large numbers of virtual machines on them, and you're also using thin provisioning, that can require a fair amount of locking overhead. So if we have machines that are constantly being expanded, the way that disk allocations are handled when we need to grow a thin provisioned virtual disk, we need to lock the file system temporarily. That can cause difficulties, and depending on the volume you're doing, supporting more than 20 or 25 or 30 virtual machines on one data store might not be practical. If we have a VAI-enabled infrastructure that supports hardware-assisted locking, or hardware-assisted zeroing, or hardware-assisted deleting, or even hardware-assisted cloning, that can all improve the performance of our storage infrastructure quite a lot, and also make things like thin provisioning work on a larger scale. And then we can create larger data stores, and ensuring that we provide sufficient capacity from a performance point of view, having that stored across multiple disks, using whatever form of RAID is available within your storage infrastructure, and then having large data stores with larger number of virtual machines on it becomes much more practical, and you're not going to run into problems down the road. But generally, we don't want to take one LUN and divide it into multiple data stores, even though we should make sure that we don't create LUNs that are excessively large, or at least that we don't put excessive numbers of virtual machines into. We really should have one virtual disk in our storage infrastructure represent one data store within VMware, and that's going to be much, much easier to manage. So I'm going to say all available space. And then just finish. So a reasonably straightforward process. We can see I now have a data store called ESX01-02. It says it's normal, plenty of capacity available. It looks exactly like we would have expected it to. But if we take a look over to the side here and I scroll over, we can see hardware acceleration says it's not supported. Now this is local storage anyway, so these VAI concepts for hardware assisted locking and so on don't apply for local storage, but my shared storage is not going to support that either. But if I was looking at iSCSI storage or fiber channel storage, I would definitely want to see what's listed there. And if it just says supported, it supports all the extensions. It might have specific ones listed there as well. So if I go back into the properties here, if I right click on it, we can see we can browse the data store. We can start putting virtual machines on it as we like. We can upload and download files through the data store browser as well. Or if you have SSH turned on to your hosts, you could connect to them using secure copy, using something like WinSCP or whatever secure copy client for the OS you prefer. If I go into the actual properties for the data store though, we can see there's a few things that we can do. If I originally created the LUN on the storage infrastructure on the SAN as 200 gigs, now this is local, but assuming it was coming off of the SAN, and I went and added space to that or expanded it by adding disks to it, then potentially my LUN would now be 2 terabytes, 8 terabytes, something much more than the very low numbers that I'm using here anyway. And what we would need to do is we would actually have to extend VMFS into that newly available space, and that doesn't happen automatically. This is very, very similar though to if you change the size of a LUN that's presented to a Windows server, a Linux server, or any other kind of server. Once the disk all of a sudden magically becomes bigger, somehow we need to expand our file system into that space. If there was a larger LUN presented all of a sudden, we could go in and increase the size of this data store, or adding additional devices as well. And if we were to do that, we would see them listed as extents here. So I could take multiple disks, either locally or coming from my SAN, and combine all of those into a data store. Certainly we should use RAID. Certainly we should have multiple disks per data store, but do we really need to have multiple RAID sets combined making up a data store? I don't think so really. Although again, maybe your storage infrastructure is guiding you to do that for some reason because it doesn't support some of the more advanced designs that you might want to do. And by the same token, having multiple data stores per LUN doesn't really make sense either. If we're using proper virtualized storage, then we can easily carve up exactly the size devices that we want and try to keep a one-to-one relationship of a SCSI block device and one file system on top of that. And that is by far the easiest way to do things. So we'll talk a little bit later in another video about path selection as well. This is not particularly important for local storage because we don't have multiple redundant paths. But when we start talking about iSCSI and fiber channel and trying to do that in a highly available and well-performing way, there's lots of considerations we'll need to put in on how multipathing will work and how path failover will work and how path placement will work. That gave us a pretty good idea of how to take a disk that VMware recognizes and format it with the VMFS file system to be able to place virtual machines on it. We can place other types of files there, but effectively the only real files that we can work with adequately here are virtual machines, ISO files, potentially updates or something that you're going to want to apply to the host. It's not really a general purpose file system that we would use for just anything. But I will take a look in another video as well at going onto the console and seeing how these VMFS volumes are presented inside the shell.